So today we're looking at integration of exponential functions. First we're going to look at differentiating exponentials because then we can get a pattern about how to anti-differentiate or integrate them. So what we do know is that when we differentiate e to the ax, we get a e to the ax. So the a just comes down the front. For example, if we're differentiating f of x e to the negative 4x, the negative 4 just comes down the front and it becomes negative 4e to the negative 4x. Just be aware too that even though we talk about differentiation, the power dropping by 1, with e it doesn't happen, it stays as the same power. So just remember that integration is just the reverse process of differentiation. So if we're looking at a e to the ax, so what we're doing is taking this and working backwards. We know that it will integrate to get e to the ax plus c for our constant. So if we divide both of those sides by a, so here and here, we can get the rule. So if we integrate e to the ax dx, we can get e to the ax over a plus c. And that's our rule for integrating exponentials. So we're going to apply it in a few examples. So first of all, we're looking at 6e to the 4x. So the 4x just stays the same, and because of the 4 in front of the x, we just end up dividing by 4. That's our a. So the 4x there comes down the bottom over there. The 6 and the 4 cancel out. They can both divide by 2. So 6 divided by 2 is 3, and 4 divided by 2 is 2. So we end up with 3e to the 4x over 2 plus c. Let's have a look at another example. So this one is a little bit different because you can see that our e to the 3x is actually on the bottom line as our denominator, part of our denominator. For us to be able to integrate it, we need to move it to the top line. So we use our negative indices laws to bring it up to the top line, and we just make it a negative power. Note that the 2 just stays there, it's just the function e to the 3x comes up to the top line and becomes negative 3x. So negative 3x stays the same, but because of the negative 3 in front of the x, we divide by negative 3 as well, and we just join it up with the 2 on the bottom line. So 2 times negative 3 is negative 6. Now because we didn't start with negative indices and we started with the indices on the bottom line, we would tidy it up and take it down to the bottom line again and just leave it as e to the 3x. So that's just coming back down to the bottom line in that one there. Right, we'll try some harder examples now. So we've got this one here, so we've got the square root of e to the 3x plus 8 over e to the 4x. Now if we can remember our fractional indices rules, so the 3, we can rewrite that as e to the 3 over 2x. So because that's a square root, that's where the 2 comes from, and the 3 comes from the power of 3x. You can write it as 3x over 2 or just 3 over 2x. It's the same thing. Again, this one is very similar to the previous one. We've got e to the 4x on the bottom line, so we can bring it up to the top line and make the power negative. Okay, so let's integrate it. So the power, of course, stays the same, or the function of e stays the same. So it stays as e to the 3 over 2x, but because of the 3 over 2 in front of the x, that's what we divide by. We'll tidy that up in a minute. And because of the negative 4 in front of the x, we divide by negative 4 here. So dividing fractions, easy as pie, flip the second and multiply. So we can flip that fraction upside down and multiply it. So it becomes 2 over 3. Now I've taken that and put it back into its original form now. So we've got the 2 stays there, the 3 there, and the 3 stays with the x there. And because of the divide by 2 in the power, that becomes the square root of it. Now with this one here, 8 divided by negative 4 is negative 2, so that's why that's negative is there. And we've taken the e to the negative 4x and taken it back down the bottom line. And we've got plus c on the end of it. We'll just try one more example. Okay, so this is a slightly different one again. We've got lots of e's there, functions of e's. Now because of that, we've just got one thing on the bottom, so what we can do is split it up with each thing on the numerator. So we can make it e8 to the power of 8x, over e to the 2x minus e to the 3x over e to the 2x. And we've split it up with both of them. Now, using your indice laws, if you had 8x to the power of 8 over x to the power of 2, now the x is your similar base. As long as I've got the same base, you can simplify that to 8e to the 6 by subtracting the powers. Same thing happens with these ones. You've got the same base, if you think of it like that, of e, so you can subtract the powers. So that becomes e to the 6x, and 3x minus 2x is just 1x. So we just leave it as e to the x. And now we can integrate that, so that now becomes e to the 6x over 6 because of the 6x, 6 in front of the x, and e to the x just stays the same, plus c. And that's how you integrate exponential functions.